This lesson is going to be about describing an atom and different ways that we can do that, and learning to know what atomic mass, atomic number, ion, and isotope mean in an atom and how that means differences for the subatomic particles. So the first description that we're going to talk about is called an isotope, and these are atoms of the same element that have different numbers of neutrons. Remember that atoms, if they have a certain amount of protons, the protons determine the element. So as long as the number of protons stays the same, that element doesn't change. You can see that my carbon here, I have carbon. It has 6 protons. I also have carbon here because it has 6 protons. And this is also carbon because it has 6 protons. But you can see that my number of protons, or my neutrons, changed with each one of these different atoms. You can see right here I have 6 neutrons. Here I've got 7. And here I've got 8. These are all different isotopes of carbon. They have different numbers of neutrons. It doesn't change the identity, but it does change the number of neutrons in the nucleus. It does change the mass of the nucleus because now we're adding another subatomic particle into that nucleus. And so my isotope is the word that I want you to remember. That's atoms that have different number of neutrons. Now, ions is another way that we can describe atoms that have changed a little bit. These are atoms which have lost or gained electrons and now hold a net charge. Remember that when we have a neutral atom, it's because we have the same number of protons and electrons. We have our positive charges and our negative charges, they balance each other out. If we change the number of electrons in this atom, and it's important to know that we're only changing the number of electrons in this atom because if we change the number of protons, well, one, it'd be really hard to rip a proton out of the nucleus. And two, if we could do that, it wouldn't even be the same element. So this isn't changing what element this is. These are both lithium. But this lithium has a positive charge because it only has 2 electrons. You can see that I've got 3 positive charges and 2 negative charges. And so my 2 negative charges, I guess, balance out 2 positive charges, and I'm left with 1 net positive charge. And so that is considered an ion. Now, atoms could gain electrons, which would give them a net negative charge, and we'll look at that one in a second here. So, for example, in this oxygen, here, remember, I have oxygen because I have 8 protons in my nucleus. Both of these are both oxygen, right? But in this one, I have a neutral atom because I have the same number of protons and electrons. But in this atom, I've gained 2 electrons. And so I have 8 positive charges and I have 10 negative charges. And so I'm left with a net charge of 2 minus. And so we would show this oxygen in this way to show that it was an ion. We would put that little 2 minus up above there. And so this is another example of an ion that has gained electrons instead of lost. Again, it's still oxygen because it has the same number of protons, but it has gained or lost electrons. And so another way that we can describe atoms is with the atomic number and the mass number. And now I've been talking about this throughout this video, is that the number of protons in an atom determines the identity of the atom. And we call the number of protons the atomic number. This is a very important number because it tells us what type of element this is. And so that's one number that we can use to describe our atoms. For example, if I said, I want you to tell me the element with the atomic number of 7, you would know that that's nitrogen because nitrogen has 7 protons in its nucleus. If I said that the atomic, I want you to tell me the element that has the atomic number of 1, you know that was hydrogen because hydrogen has 1 proton. As the atomic number changes, that changes the element it is, and the atomic number is a way of describing what that element is. We also have something called the mass number, and this mass number is going to differentiate between our isotopes because remember, isotopes are going to be atoms that have, or elements that have different numbers of neutrons in their nucleus. Right? The proton number stayed the same because if I have carbon 12 versus carbon 14, maybe you've heard of this before. What I'm talking about is I have a different mass in this carbon than this one. One of them has a mass number of 12, one of them has a mass number of 14, but they both have the same atomic number because they're both carbon. if that makes sense. They have the same number of protons. And so my mass number is just the sum of protons and neutrons in the nucleus of an atom. And so if I know that my carbon has 6 protons, let's say I have a mass number of 12, I would know that I have 6 neutrons. And in this one, I know that it's carbon, and so I know that it has an atomic number of 6 protons in its nucleus. But because my mass number is 14, I know that I have 8 neutrons in that nucleus because I have to have 6 plus my number of neutrons needs to add up into 14 because this is my mass number. And so those are two different numbers that we can use to describe the makeup of an atom. So let's say I was going to try to figure out the atomic number and the mass number of both of these two atoms here, my carbon and my boron. Now if I was going to try to find my atomic number, remember that's the number of protons, and so I look over my carbon and I've got 1, 2, 3, 4, 5, 6, so my atomic number is 6. And my mass number is 6 plus my number of neutrons, which is 1, 2, 3, 4, 5, 6. 6 plus 6, which would really be 12, would be my mass number of this atom. And so I can do the same thing with my boron over here. My atomic number is the number of protons, 1, 2, 3, 4, 5. And my mass number is 5 plus my number of neutrons, 1, 2, 3, 4, 5, 6. 5 plus 6, my mass number is 11. And so that's how I can figure out my atomic number and my mass number. And this can go backwards in the other direction too. Like if I have my mass number, which will really be what happens more often than not, is you have the atomic number, the mass number, and you have to figure out the number of protons in that atom. And this is how you can do that. And one thing worth mentioning as we're figuring out atomic number and atomic mass and the mass number and all of this and learning what our periodic tables is, where are these actually on our periodic table? You can see for this boron, you can always see this, I don't know, the single digit number in the lower of the two numbers. You see a 5 and you see a 10.811. Now, why is that in decimal? We'll get to that in a second. But the lower of the two is going to be my atomic number. This is saying, oops, we'll go right here. This is saying that I have 5 protons, 1, 2, 3, 4, 5, in a boron atom. Now, when I look at my mass number, if I was going to try to figure this out, I have 1, 2, 3, 4, 5 protons and 1, 2, 3, 4, 5 neutrons. And so I would say, well, my mass number is 10. Now, when you look on your periodic table, you're going to often see a decimal number. Now, this is something called the atomic mass. It's not the mass number. What it really is it is a weighted average of all of the different isotopes that occur in nature. So, for example, this number is very close to 11. The boron isotope that has a mass number of 11 would be the most abundant in nature, right? The one that's most common. And so when you're looking at your periodic table and you're trying to figure out what are the mass numbers of these, what we will often do and what you should do is you should take this atomic mass number, the one with the decimal, and you should round it to the nearest whole number and use that for your mass number because that is the most common isotope. Most of the time, boron has a mass number of 11. And so that's just one thing to note as we're looking at the periodic table. And the same thing would happen here for carbon. If I was trying to figure out what I had for a mass number here, I would see that my carbon has an atomic number of 6. It has an atomic mass of 12.0107, which is very, very, very close to 12, meaning that in the vast majority of the time, carbon has a mass number of 12. And we can see that in this isotope that we see right here. We've got 1, 2, 3, 4, 5, 6 protons and 1, 2, 3, 4, 5, 6 neutrons. And so I would have a mass number of 12. The closer this number is, or the least you have to round, the more abundant that isotope is, the one that it is closest to. Just a little piece of information there. So the goal of this video is to be able to describe an atom, knowing what an atomic mass, the number of protons and neutrons is in the atom, the atomic number, the number of protons in the atom, ion, an atom that has gained or lost electrons giving it a net electric charge, and the isotope, an atom which has a different number of neutrons in its nucleus, and what that means for an atom. And so I hope this video has helped you to be able to use those words to describe atoms and elements.